Good morning. This video should be fairly short and is just a quick summary of what we know about solving quadratic equations, which strategies we have, when those strategies are good to use, and an example of what you would be looking for when using each of those strategies. So one of the strategies that we have when solving a quadratic is the square root strategy. This strategy doesn't get a whole lot of emphasis because it's not useful most of the time. When it is useful, when you can use it, is when b is equal to 0. In other words, there is no x term. So you're looking at your quadratic, you see that you have a quadratic, but you don't see any term in that quadratic equation that just has the x. So you'll see the x squared, but not an x. Here's an example of a problem that would be good to solve using the square root strategy. If you had 4x squared minus 16 equals 0. So notice that it is a quadratic because you have the x squared and not any exponent higher. And then you have the constant term, the minus 16, but you're missing the b term. You're missing that x term. So where we would normally think of it as ax squared plus bx plus c, this one is only showing the ax squared and the c, but no x term. So when you start the activity and you have to list strategies that would be good to use to solve a particular equation, look for that. If you don't see an x term, you want to make sure that you're listing square root as one of the possible strategies you could use. To solve this equation, we would add 16 to both sides. So we'd get 4x squared is equal to 16. This is multiplication here between the 4 and the x squared. So we would divide both sides by 4, getting x squared is equal to 4. And then at this point, we would square root both sides because square rooting and squaring undo each other. This would leave us with x. Now, when we go to write the final answer, we do need to remember that what we're trying to find here is what number squared gives us 4. And most of you will think of 2, but remember that also a negative 2 would work. So 2 times 2 would give you 4, but also negative 2 times negative 2 would give you 4. And so you want both the 2 and the negative 2 as answers. So that's the square root strategy. Again, when you start the activity and you need to list some strategies that you could use to solve a quadratic, look for that. If you don't see an x term, then make sure you list square root as one of your possible strategies. Another strategy that we have for solving quadratics is completing the square. This strategy can actually be used anytime. You are not restricted on the kind of equation that you can use completing the square on. However, it would be very inadvisable for you to use this strategy when you have a leading coefficient other than 1 or when your b value is odd. And so I would recommend that you would consider this when your a value is equal to 1 and when b is even. And that's because you're going to take that b value and divide it by 2. And so we want something that will divide by 2 evenly and not leave us with some, a fraction that we then have to go and do stuff with. So an example of an equation that would be good to use completing the square on would be x squared minus 2x minus 24. Notice that the leading coefficient is a 1 and our middle number, our b value, is even. To solve using completing the square, we would first get the c on one side. So we'd have x squared minus 2x is equal to 24, so we'll add 24 to both sides. And then we have some scratch work that we do off to the side. We take our b value and divide it by 2, and we save that number. So I'll put the little asterisk over there. We're going to save that because that's what's used when we get to the factoring step. Then we take the result of that and we square it, and that is the number that we add to both sides of our equation. And remember, we add it to both sides in order to keep it balanced. On the right-hand side here, I have 24 plus 1 is equal to 25. And on the left-hand side, I will factor that, and it will always factor into with whatever number you have over here halfway through your work. So we have, what do we have? X minus 1 all squared. Now we square root both sides, And just like in the last problem, like we're looking for what squared gives us 25. And so on the right-hand side, I do end up with plus or minus 5. On the left-hand side, when I square root something squared, I left with what's inside. And then to get x by itself, we will add 1 to both sides. This gives us two equations here, or two potential answers. We would have 1 plus 5 as one of them, so x could be equal to 6, and then we have 1 minus 5, or x is equal to -4. Notice that with both of these problems that we've done so far, we could also use factoring. If you look at this one, it is also the difference of two squares, and so you could solve that by factoring. You could also use the quadratic formula. Just remember that your b value would be 0. This one could be factored, and it could also be solved using the quadratic formula. So we do have some options there. Third strategy that we've covered is factoring, and this one generally is, we'd want to use it whenever we can. Provided that the numbers aren't too big and it's not going to take us too long to do it. Factoring generally has a nice clean solution to it, and yeah, it's got the least number of steps, but it does require us to think. So we do have to go through the numbers and make some choices and decisions along the way. This is a good example of the factoring, and this is going to take us through our slide and divide process, so we have a chance to review that. If you were at the factoring tutoring session that I did, I ended it by going through like a flow chart where you would go through the different questions that you would ask yourself as you are factoring. First question you want to ask yourself is there a common factor? If there is, you're going to factor it out first. Then you would ask yourself, is this the difference of squares or some other special case? So in this example, no, we do not have any common factors, and no, this is not a special case. So that means we start turning towards, okay, it's a trinomial. If you have a coefficient other than 1 out front, that is when we would kick in our slide and divide. So we'll have x squared minus 9x plus 60. Remember that this is a totally different problem. We have altered the problem by sliding the 3 down and doing that multiplication. So whatever we've done, we do have to undo it. Just remember that this is a different problem. Looking at, let's try that again. At our factors, we are looking for two numbers that multiply to 60 but add up to -19, and if you can't think of them off the top of your head, you do need to start listing them out. And when I get to 4 times 15, that is my combination that I'll use, because 4 plus 15 is 19. Remember that we're trying to get a -19, so in this case they would have to both be negative. So we'll have x minus 4, x minus 15. That's not the end of the problem though, because we altered the problem up here when we did the sliding. So now we have to make sure that we undo it by dividing. So we'll divide by 3 since we multiplied by 3 up here. If it does not divide evenly, you slide your denominator back out in front. If it does, you can just go ahead and do the division. And then we have the zero product property applied here. We have two things that are multiplied together. The product is 0, which means either the first factor is 0 or the second factor is 0, but there's no way around that. And so we set them each equal to 0. On the right, we'll add 5 to both sides, so x could be equal to 5. Over here, we'll add 4 to both sides and then divide by 3. Notice that you don't have to show the mechanics of what you're doing there. If you have x minus 5 equals 0 and the next line is x equals 5, I will know that you added 5 to both sides, and that's perfectly doable in your head, so you do not need to write it out. And so, sorry, I slid the screen. So the solutions are x equals 4/3 and x is equal to 5. Last strategy. Last strategy is the quadratic formula, which is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And this strategy, really, you can use this strategy anytime. This will give you an answer to any quadratic. It is, yeah, I mean, we have to know it because some of our other strategies either won't work or they won't work well. So for your activity, you will be looking at a series of problems. You're going to, with your group, decide on what strategy would be best or would be doable for that particular problem. And then of the problems, you will have to choose 6 of them to solve with your group. You have to demonstrate the quadratic formula twice. You have to demonstrate factoring twice, completing the square once, and square rooting once. So make sure you're keeping a good eye out for the problems that are good to solve with the square root and with completing the square.